In the darkness of the cosmos, beyond the light of ordinary stars, lies a mystery that defies common understanding. For decades, the concept of black holes has dominated astrophysics, a point of infinite density where nothing escapes, not even light. They are painted as cosmic monsters, devouring everything in their path. But what if this picture, so firmly etched into scientific thought, is incomplete? Some researchers argue that black holes might not exist at all. Instead, there may be stranger, more terrifying objects, entities called gravastars. Unlike the traditional black hole, gravastars may not collapse into singularities. They could be hollow, filled with exotic states of energy, and potentially more catastrophic for the universe than black holes ever were. With that said, let us begin. The traditional view of black holes is both elegant and unsettling. When a massive star exhausts its nuclear fuel, it collapses under its own weight. Gravity crushes the star beyond recognition, creating a singularity, an infinitely dense point where all known laws of physics break down. Around this singularity lies the event horizon, a boundary that marks the point of no return. Anything that passes this limit, stars, planets, even light itself, becomes trapped, forever lost to the abyss. But some researchers have asked a daring question: what if this picture is incomplete? What if the universe does not allow infinities to exist in nature? This line of thinking led to an alternative model, one that replaces the singularity with something radically different, a gravastar. The word itself, short for gravitational vacuum star, describes a bizarre object that could mimic the appearance of a black hole while hiding an entirely different structure beneath its surface. Instead of a singularity, a gravastar contains a strange interior made of dark energy, an energy with negative pressure that pushes outward. Imagine a cosmic bubble. The outer shell is composed of ultra-dense matter, while the inside is a void filled with this exotic energy. The pressure from within balances against the crushing pull of gravity from without, preventing total collapse. To a distant observer, the gravastar looks nearly identical to a black hole, because its shell bends light and space in similar ways. Yet its internal reality is a haunting alternative. The very idea unsettles scientists because gravastars don't just replace black holes, they could undermine decades of astrophysical understanding. If gravastars exist, then what we thought were cosmic abysses might actually be hollow shells, filled not with a singularity, but with dark energy waiting to tear at the fabric of spacetime itself. And this raises a chilling possibility. The universe may be filled not with black holes, but with entities even stranger, whose true nature is still concealed from us. At first glance, it might seem that gravastars are just another speculative idea among many in astrophysics. But the reason they provoke such fascination is their uncanny ability to mimic black holes so perfectly that even advanced telescopes may not be able to tell them apart. To an outside observer, the difference is nearly invisible. Light curves around a gravastar in almost the same way it does around a black hole, and matter falling toward its shell emits radiation that looks strikingly similar to what we expect near an event horizon. This deceptive similarity makes gravastars a kind of cosmic imposter, hiding in plain sight. What truly separates them lies beneath the veil. Unlike a black hole, which offers no surface, only the horizon of no return, a gravastar possesses a physical boundary. A thin, ultra-dense shell of exotic matter compressed to unimaginable levels. This surface means that infalling material wouldn't vanish into a singularity, but rather slam violently against the shell. The resulting burst of energy would radiate back into space in strange, unpredictable patterns. If such signals were detected, they could betray the existence of gravastars. Scientists have tried to model these collisions, imagining scenarios where entire stars or clouds of gas smash into a gravastar. Instead of the energy being swallowed completely, the object would reverberate like a cosmic drum, producing echoes of gravitational waves. Unlike the clean waveforms produced by black holes merging, these echoes would hint at something stranger lurking beneath the surface. Though no definitive evidence has yet been confirmed, researchers are actively searching for such signals in the data recorded by gravitational wave observatories like LIGO and Virgo. If found, it would be a revelation. Proof that what we thought were black holes may, in fact, be these exotic stars of dark energy. The theoretical underpinnings of gravastars reach into the deepest mysteries of modern physics. Central to their design is the concept of dark energy, the mysterious force that drives the accelerated expansion of the universe. In the gravastar model, this energy is trapped inside the shell, creating an interior that is not crushingly dense, but instead vacuum-like and expansive. In essence, a gravastar is a bubble of dark energy, stabilized by a boundary of ultra-compact matter. This makes them radically different from black holes in terms of internal structure. A black hole is an endpoint, a place where matter collapses endlessly and vanishes from the observable universe. But a gravastar could be described as a balance point, a fragile dance between collapse and expansion. The inner pressure resists the pull of gravity, halting the formation of a singularity. It is as if nature, unwilling to allow infinities, builds a firewall of sorts, replacing the ultimate abyss with a cosmic equilibrium. Such a replacement carries profound implications. If gravastars exist, then the most extreme objects in the universe are not destroyers, but rather strange storage vessels of energy. Their shells would be unimaginably dense, possibly composed of exotic particles yet undiscovered. Their interiors would hold a fragment of the same energy that pushes galaxies apart. In this sense, gravastars become more than just alternatives to black holes, they become laboratories of cosmology, tying together the fate of stars with the very engine that drives the expansion of the cosmos itself. The terrifying part lies in their potential instability. If the balance between shell and interior is disturbed, say, by collisions or mergers, the result could unleash catastrophic amounts of energy. Instead of swallowing matter silently, a gravastar could erupt violently, spilling its dark energy outward like a ruptured cosmic balloon. Such an explosion would dwarf even the mightiest supernova, a nightmare scenario capable of reshaping galaxies. For observers, the greatest difficulty lies in distinguishing gravastars from their black hole counterparts. The images captured by the Event Horizon Telescope, such as the famous picture of the shadow of M87 central black hole, could, in theory, also depict a gravastar. The glowing ring of plasma encircling the dark void would look nearly identical in both cases, making the distinction maddeningly elusive. However, researchers have proposed subtle ways to tell them apart. One idea is to study the way light flickers near the edge of these objects. If matter strikes a gravastar's shell, it may produce a burst of radiation that briefly escapes before being absorbed or scattered. These flashes could manifest as irregular spikes in brightness, patterns that wouldn't occur with a true black hole. Similarly, the gravitational waves from mergers may hold hidden fingerprints. Instead of fading smoothly, as with black holes, gravastar collisions could leave behind faint after-echoes, signatures of vibrations against the inner shell. The search for these differences is ongoing, and each new observation forces astronomers to reconsider their assumptions. If one day a signal emerges that cannot be explained by black hole physics, the gravastar hypothesis will leap from speculation to reality. The unsettling truth is that, even now, the universe may already be filled with these imposters. Every time we point to a region of darkness and say there is a black hole, we might instead be staring at something even stranger, an object that not only defies collapse but may conceal within it the very energy that governs the fate of the cosmos. The very existence of gravastars forces us to confront a deeper philosophical question: do we truly understand gravity at its most extreme? General relativity, Einstein's masterpiece, has explained the movements of stars, planets, and galaxies with exquisite precision. It predicts black holes with astonishing accuracy, and yet it also predicts the singularity, a point where physics breaks down. Gravastars, however, challenge this picture, suggesting that singularities may not form at all. Instead, a new law of nature might intervene, redirecting the collapse into something unexpected. This possibility has far-reaching consequences. If gravastars exist, then the black holes we believe anchor galaxies, those massive dark giants at the centers of galactic cores, may be misidentified. Our own Milky Way is thought to harbor a supermassive black hole called Sagittarius A*, but if the Gravastar hypothesis is correct, we might be orbiting something altogether stranger. Instead of an object that swallows and hides, it could be a shell filled with dark energy, a bizarre container that quietly shapes the dynamics of our galaxy. The implications don't stop there. If gravastars replace black holes, then our understanding of cosmic evolution changes dramatically. Stellar deaths, galactic mergers, even the recycling of matter in the universe, all of these processes would need to be reimagined. Gravastars would act not as cosmic endpoints, but as sealed vaults, locking away matter and energy in ways we had never anticipated. This would leave less material available to form stars and planets in future generations, potentially altering the entire rhythm of cosmic history. One of the most chilling aspects of gravastars is their potential volatility. Unlike the silent, stable hunger of black holes, a gravastar is a precarious balance between collapse and expansion. Its outer shell, a wafer-thin but ultra-dense boundary, is under immense tension. Inside, the exotic vacuum energy exerts outward pressure, straining against the confining shell. Should that balance fail, the consequences would be apocalyptic. Consider the energy contained within such an object. If the shell ruptures, the dark energy could erupt violently, unleashing an explosion unlike anything we have ever witnessed. Some theorists speculate that such an event could dwarf gamma-ray bursts, the brightest explosions known in the cosmos, by orders of magnitude. In fact, some of the unexplained, short-lived flashes we detect in deep space may be candidates for these catastrophic outbursts. If so, gravastars may not only exist, but may have already revealed themselves through the universe's most violent fireworks. Even the mergers of gravastars could pose unimaginable dangers. Black hole collisions are already among the most energetic events in the universe, producing ripples in space-time itself. But gravastar mergers might release something more sinister. Not only gravitational waves, but bursts of exotic energy spilling into the cosmos. Such events could destabilize surrounding space, disturbing the delicate balance of galaxies and perhaps even altering local cosmic expansion. Gravastars, then, are not merely imposters, they could be ticking time bombs, scattered across the universe, waiting to erupt. From an observational standpoint, the difficulty lies in catching a gravastar in the act. The vast majority of time, these objects would appear calm, indistinguishable from black holes. Their surfaces would reflect no light, their gravitational grip would warp space-time, and matter falling into them would heat up and glow, just as it does near black holes. Only in the rare moments of collision or instability would their true nature be revealed. To search for such clues, astronomers are combing through data from telescopes around the world. Instruments like the Event Horizon Telescope, which captured the shadowy silhouette of M87*, may eventually uncover details too fine for the black hole model to explain. Meanwhile, gravitational wave detectors are refining their sensitivity, hoping to catch the faint echoes predicted by the gravastar model. These echoes would be like aftershocks, subtle reverberations in the fabric of spacetime that refuse to fade cleanly, whispering of a hidden surface inside the dark. The stakes are immense. If gravastars are confirmed, physics would be forced to confront one of its most unsettling realities, that the universe hides not infinities, but exotic vaults of energy, masquerading as voids. It would be the revelation of a grand deception, where what we once thought of as the most destructive forces in nature are in fact imposters, concealing an even greater and more dangerous truth. The black hole, long the king of cosmic nightmares, would be dethroned, replaced by something stranger, and perhaps far more terrifying. The Gravastar hypothesis also sparks debates about the very nature of space and time. In black hole physics, the singularity represents a place where space-time itself collapses into nothingness. Gravastars, however, reject this annihilation. Instead, they imply that space-time might resist collapse by forming a new state of matter-energy equilibrium. This raises profound questions. Is space-time flexible enough to build boundaries, walls of sorts, around dangerous infinities? Could gravastars be the universe's way of shielding itself from self-destruction? Some theorists even suggest that gravastars could serve as windows into the quantum structure of reality. If their shells are composed of exotic particles, then studying them could provide a glimpse of physics beyond the standard model, domains where quantum mechanics and gravity intertwine. This makes gravastars more than astrophysical curiosities. They become potential testing grounds for the unification of physics itself. Detecting one could unlock secrets of quantum gravity, illuminating how the smallest scales of existence connect to the largest. And yet, this makes them all the more unsettling. For if gravastars harbor properties that transcend our current physics, their behavior may be unpredictable. A rupture might not just unleash catastrophic energy, it could warp the very structure of space around it, bending or tearing spacetime in ways unimaginable. Instead of being silent monsters like black holes, gravastars could act as cosmic saboteurs, harbingers of instability written into the laws of the universe. Throughout the history of astronomy, every great discovery has forced us to reconsider our place in the cosmos. When black holes were first proposed, they seemed almost absurd, regions of space where light could not escape. Over time, evidence built steadily until they became accepted as real. Now, gravastars threaten to disrupt that certainty once more. Are we on the verge of another paradigm shift, one that replaces black holes with even stranger entities? Some researchers argue that the gravastar idea is simply too speculative. They caution that until hard evidence arises, the black hole model remains the best explanation. After all, black holes have withstood decades of tests, from the orbits of stars around Sagittarius A** to the precise predictions of gravitational waves detected by LIGO. Gravastars, by contrast, are still largely theoretical. And yet, the very fact that they can explain certain features, such as potential echoes in gravitational wave data, keeps the debate alive. This tension between theory and evidence is what makes gravastars so compelling. They occupy a space between reality and imagination, forcing scientists to stretch the boundaries of their thinking. And whether or not they exist, the very act of searching for them deepens our understanding of the universe. It compels researchers to ask difficult questions, to test new ideas, and to confront the unsettling possibility that what we think we know about the cosmos might be an illusion. The possibility of gravastars also forces us to reconsider the fate of matter itself. In the black hole model, matter is swallowed and crushed beyond recognition. Whether it remains hidden forever or somehow escapes through mechanisms like Hawking radiation is still debated. But in the gravastar scenario, matter never reaches a singularity at all. Instead, it collides with the dense outer shell, releasing energy before being absorbed into the structure. This means the universe may not lose matter to infinities, but rather lock it away in sealed prisons of exotic physics. This imprisonment carries disturbing implications. Over cosmic timescales, countless stars, gas clouds, and even entire solar systems may end up trapped in these hollow shells, stripped of their individuality and compressed into the boundary of a gravastar. The universe could be filling up with these dark coffins, each one a silent monument to collapsed stars. Unlike black holes, which we imagine as voids, gravastars would be more like cosmic tombs, preserving their victims in a distorted form. The image is chilling, a galaxy dotted not with singularities but with shells of unimaginable density, each one hiding an interior of dark energy. Instead of silent consumers, they become dark storehouses, hoarding matter and energy while masquerading as familiar black holes. If this is true, then the night sky is filled with imposters, objects that we have misnamed, misunderstood, and underestimated for generations. Gravastars may not only exist. They may already dominate the cosmic stage, quietly shaping the evolution of the universe while concealing their terrifying true nature. If gravastars are real, they would redefine the way we think about stellar death. Traditionally, massive stars live fast and die young, their immense weight crushing their cores once nuclear fusion can no longer resist gravity. The collapse is so total that it creates a black hole, according to standard theory. But in the gravastar model, the collapse halts just before the singularity forms. Instead, the star stabilizes into this eerie shell, surrounding a void of exotic energy. This alternative ending for stars could mean that the universe is filled with far more gravastars than black holes. Some of the supposed black holes detected by astronomers, whether stellar mass objects formed from dying stars or the supermassive giants in galactic centers, could actually be gravastars in disguise. If so, our catalogue of black holes would be deeply flawed, and our entire map of cosmic evolution would need to be rewritten. What's more unsettling is the possibility that gravastars could come in multiple varieties. Some may be tiny remnants of stars, others may have grown monstrous through collisions and mergers. Just as black holes can span a wide range of sizes, from a few times the Sun's mass to billions of times larger, gravastars too may stretch across this spectrum. But unlike black holes, they carry the hidden potential of violent instability. Imagine a supermassive gravastar, millions of times more massive than the Sun, suddenly rupturing at the heart of a galaxy. The explosion would not merely disrupt nearby stars, it could alter the entire structure of the galaxy itself. Gravastars also force us to confront the role of dark energy in the universe. We know that dark energy is real, it is the mysterious force accelerating the expansion of the cosmos. But its nature remains elusive. What if gravastars are repositories of this energy, small-scale pockets of the same force that drives galaxies apart? If so, then every gravastar becomes a miniature reflection of the universe itself, a shell containing a void of expansion energy. This connection is profound. It would mean that the same force shaping the large-scale structure of the cosmos also governs the fate of dying stars. The cycle of stellar death would not simply create voids of nothingness, but containers of the very energy that fuels cosmic growth. Gravastars, then, would not only challenge black holes, they would bridge the gap between stellar astrophysics and cosmology, uniting two seemingly separate realms of science. But this possibility also carries danger. If gravastars truly contain dark energy, then rupturing one would not simply release matter and radiation, it could inject raw expansionary force into its surroundings. What would happen if such energy spilled into normal space? Could it locally accelerate expansion, ripping apart star systems? Could it destabilize galaxies? These questions remain unanswered, but they suggest that gravastars are not passive objects. They are, instead, dangerous reservoirs, cosmic pressure cookers with consequences that reach far beyond their own boundaries. The search for gravastars is not purely theoretical. Astronomers have begun to look for observational evidence that might distinguish them from black holes. One line of investigation focuses on gravitational waves, the ripples in space-time detected when massive objects collide. Black hole mergers produce waveforms that rise to a peak and then fade smoothly as the merged object settles into stability. But gravastars, with their dense shells, might ring like cosmic drums, producing echoes after the initial collision. These echoes would be subtle, buried deep in the noise of detectors. Yet some researchers claim to have seen hints of them in the data. While the evidence is far from conclusive, even the suggestion has stirred debate. If confirmed, these echoes could be the first true fingerprints of gravastars, hidden in the rippling fabric of space-time itself. Another avenue of research comes from studying the accretion disks, the swirling rings of matter spiraling into compact objects. Around black holes, matter falls past the event horizon and disappears. But around gravastars, some of that material could rebound off the shell, creating flares or bursts of light not expected from black holes. Observing such anomalies would require incredible precision, but with the next generation of telescopes, it may be possible. The irony is striking. The universe may have already shown us gravastars, but our assumptions have blinded us. Every shadow image, every burst of radiation, every gravitational wave has been interpreted through the lens of black holes. Only by daring to ask, what if they are not black holes at all, do we begin to see the possibility of imposters? And if these imposters are real, they are not only stranger than black holes, they may be far worse. One of the most unnerving aspects of the Gravastar model is how perfectly these objects hide in plain sight. To the naked eye of our instruments, they behave almost identically to black holes. Their gravitational pull warps spacetime with the same intensity. Their silhouettes, captured against glowing matter, appear as dark voids encircled by fiery halos of plasma. Even the dance of stars around them, like those near the center of our Milky Way, offers no immediate distinction. Gravastars, in essence, are masters of disguise. This means that for decades, astronomers may have been misled. Every time a black hole was discovered, what if some of those sightings were actually gravastars? The thought is haunting. The scientific triumph of detecting black holes may be built on a mistaken identity. And unlike black holes, which at least obey our broad understanding of general relativity, gravastars plunge us into far less charted territory where dark energy, exotic matter, and quantum gravity collide. The deception is not malicious. These objects are not intelligent imposters. But the universe itself seems to be playing a trick on us, cloaking its most bizarre creations in familiar disguises. If gravastars are real, then nature has constructed the ultimate cosmic illusion. And beneath that illusion lies something far more unstable, unpredictable, and possibly catastrophic. The danger of gravastars is not limited to their explosive potential. Their very presence challenges the stability of our theories. For decades, physicists have relied on black holes as natural laboratories to test the limits of gravity. By observing them, we test relativity, probe quantum theories, and attempt to understand the boundary between known physics and the unknown. But if gravastars masquerade as black holes, then many of these tests may already be compromised. Consider the implications. Measurements of gravitational waves, orbital dynamics, and high-energy radiation might all contain errors born from false assumptions. If what we thought were black holes are actually gravastars, then decades of carefully built models may require revision. Theories of galactic formation, stellar evolution, and even cosmic structure could be subtly, but profoundly, wrong. Gravastars do not just challenge astrophysics, they threaten to destabilize the very framework of modern cosmology. And then there is the unsettling thought of interaction. What happens if a gravastar and a black hole collide? Or if two gravastars merge? The results could unleash phenomena we cannot yet model: rips in spacetime, bursts of exotic energy, or even localized changes in cosmic expansion. These scenarios push science into speculative territory, but they also highlight a deeper truth: gravastars, if real, are not passive. They are active players in the cosmic drama, and their roles may be far more destructive than anything black holes could accomplish. There is also the philosophical terror of gravastars. Black holes, for all their mystery, are at least predictable in their simplicity. They swallow, they grow, and they fade only slowly through radiation. Gravastars, on the other hand, embody contradiction. They are not infinite, but they mimic infinity. They are not voids, but they appear as voids. They are filled with energy, yet sealed away in silence. They are cosmic paradoxes given physical form. This paradox unsettles more than just science, it unsettles meaning. If the most powerful objects in the universe are imposters, what does that say about the limits of observation? If the universe hides its truth so carefully, then how many other illusions might it conceal? Gravastars are a reminder that reality is not always what it seems, even on the grandest scales. And the terror grows when one considers their potential abundance. Every galaxy, every star system near a so-called black hole may actually orbit a gravastar. These are not rare anomalies, they could be everywhere, shaping the universe in silence. Instead of resting on the certainty of black holes, we may be surrounded by imposters whose shells contain a volatile secret. The thought transforms the night sky from a place of elegance to one of unease, as each dark void may not be what we think it is. Gravastars do not merely replace black holes, they mock them, and in doing so, they mock our certainty. In the quest to prove or disprove gravastars, technology is both our greatest ally and our greatest limitation. Instruments like the Event Horizon Telescope give us breathtaking images of the shadows of compact objects, but they lack the resolution to reveal the crucial details that would separate a black hole from a gravastar. To the telescope, both appear as dark silhouettes framed by glowing rings of matter. The deception remains intact. Gravitational wave detectors, however, offer a glimmer of hope. When massive objects collide, they send vibrations through space-time itself, carrying unique signatures of the merging bodies. Black holes, being purely absorptive, produce waveforms that fade cleanly. But gravastars, with their dense shells, could reverberate. The after-echoes they might produce would sound like faint ripples after the initial crash, a ghostly signature of a solid surface hidden beneath the darkness. Some data has hinted at anomalies resembling these echoes, though the evidence remains hotly debated. If confirmed, such signals would not just suggest gravastars, they would demand a rethinking of everything we thought we knew about compact objects. The unsettling truth is that even now, as we study the ripples of space-time, we may already be listening to the voices of gravastars, hidden in plain sound. The implications of gravastars stretch far beyond astrophysics. If these objects truly contain dark energy within their interiors, they may be linked to the ultimate fate of the universe. Dark energy drives the acceleration of cosmic expansion, slowly pushing galaxies away from one another. But what if gravastars act as nodes or reservoirs of this force? What if the deaths of stars are not just the end of life cycles, but contributions to the very engine of universal expansion? This would mean that every gravastar is more than a stellar corpse, it is a participant in the cosmic future. Each one could add to the energy budget of the universe, tilting the balance between eternal expansion and potential collapse. In this way, gravastars may not only mimic black holes, they may secretly guide the destiny of the cosmos. But with such power comes peril. If gravastars rupture, they might release their dark energy violently, accelerating expansion in local regions or destabilizing entire galactic environments. Imagine a galaxy where the central black hole is actually a gravastar. If it were to break apart, the eruption could alter the very fabric of space-time in its vicinity, scattering stars and destabilizing planetary systems. Such scenarios transform gravastars from silent guardians into potential cosmic catastrophes waiting to unfold. To grasp the full weight of the gravastar concept, one must confront the possibility that the universe is far stranger than we dared imagine. Black holes already stretch the limits of belief. Invisible wells that swallow light, time, and space. But gravastars go further. They are hollow shells filled with the very energy that drives the cosmos apart, cloaked in the guise of black holes, hiding their true nature from our gaze. For centuries, astronomy has been about peeling back the layers of deception the universe casts upon us. The Earth was not the center of the cosmos. The stars were not fixed points. The Milky Way was not the entire universe. Each revelation forced us to surrender our assumptions. Gravastars may represent the next great surrender, the admission that the most terrifying objects we thought we understood are, in fact, imposters. And in this lies the chilling essence of the Gravastar hypothesis. It is not just a replacement for black holes, it is an accusation. It suggests that our instruments, our theories, even our triumphs have been fooled by nature itself. The cosmos has not revealed its monsters fully, but cloaked them in masks. Gravastars may be those monsters, waiting in silence, their shells containing the same force that dictates the fate of the universe. If this is true, then black holes were never the true nightmare. Gravastars were, and they are worse. The Gravastar debate also raises uncomfortable questions about the reliability of observation itself. Modern astronomy is built upon indirect evidence, light, gravitational waves, radio emissions. We never truly see a black hole or a gravastar, we see what happens around them. This creates a fertile ground for deception. Gravastars, in this sense, exploit the very limits of human perception and technology. They masquerade perfectly within the gaps of our instruments, reminding us that what we interpret as truth may only be the shadow of something stranger. This subtle deception highlights the fragility of science at the edges of knowledge. In most areas of physics, predictions can be tested, repeated, and confirmed. But when it comes to cosmic giants, the evidence is fleeting, rare, and often ambiguous. It is here, in the uncertainty, that gravastars lurk. The possibility that some, or perhaps many, black holes are imposters forces a kind of intellectual humility. The universe may not be the clean, logical system we imagine. It may instead be layered with illusions, each one waiting to unravel at the next breakthrough. And therein lies the real terror. Gravastars remind us that the cosmos is not obliged to be understandable. Our models, no matter how elegant, may collapse when confronted with reality. The gravastar is not just a scientific hypothesis, it is a warning. To better imagine a gravastar, picture a bubble drifting through space. Its surface is impossibly thin yet unimaginably strong, a boundary of exotic matter compressed to densities that defy comprehension. Inside, there is no singularity, no crushing point of infinite density, but rather a vacuum filled with dark energy, expanding outward, pressing against the shell. This balance between inward gravity and outward pressure creates the stability of the gravastar. But this balance is precarious. Like a balloon inflated too far, the shell may quiver under the strain. Collisions, mergers, or even the slow accumulation of matter could tip it into instability. The rupture of such a shell would not simply release energy, it would release the kind of force that shapes the expansion of the universe itself. In a way, gravastars become metaphors for fragility hidden inside strength. Outwardly, they appear as the most invincible objects in existence, devouring stars and warping space. But inside, they are tenuous structures, holding back chaos with delicate equilibrium. If black holes are eternal prisons, gravastars are ticking clocks, objects whose countdowns we cannot yet measure. This makes them not only strange but profoundly dangerous, as their failure could trigger explosions capable of rewriting the architecture of galaxies. The fear surrounding gravastars is amplified by their potential abundance. If they are not rare oddities but common outcomes of stellar collapse, then the universe may already be full of them. Every black hole at the center of every galaxy could instead be a gravastar, each one storing unfathomable amounts of dark energy within fragile shells. Imagine billions of ticking cosmic engines scattered across the cosmos, silent but volatile, their true nature hidden. If this is the case, then the universe itself is unstable in ways we cannot yet fathom. The cosmic balance we observe, the slow drift of galaxies, the steady cycles of stars, could be an illusion, dependent on the continued stability of countless gravastars. Should even a few rupture, the consequences could cascade across cosmic scales. Gamma-ray bursts, gravitational waves, and violent outflows of exotic energy could reshape the universe's landscape. Some speculate that gravastars may even explain phenomena we already struggle to understand. Could certain unexplained bursts of high-energy radiation be failed gravastar shells? Could mysterious fast radio bursts be echoes of their instability? Each new unexplained observation now carries an unsettling possibility. Behind it may lurk the hand of a gravastar, breaking its disguise. The possibility that gravastars explain unexplained cosmic phenomena adds weight to the theory. For decades, astronomers have observed violent events in the universe that defy simple categorization. Gamma-ray bursts, for instance, are among the brightest explosions ever recorded, yet their origins remain puzzling in some cases. While many are linked to collapsing stars or merging neutron stars, others are more mysterious. Appearing suddenly, burning with unimaginable intensity, and then vanishing. Gravastars provide a chilling alternative. The rupture of one of these exotic shells could release an outpouring of energy unlike anything else, masquerading as a gamma-ray burst. Another mystery lies in fast radio bursts, brief, intense flashes of radio waves that last only milliseconds but shine brighter than entire galaxies. Their origins are still debated, with theories ranging from magnetars to alien technology. Yet, gravastars offer another candidate. A slight instability or crack in a gravastar's shell could produce a violent, short-lived emission of energy, visible as a radio burst before the object stabilizes again. If true, these fleeting signals may already be warnings that gravastars are real, whispering their presence through the cosmos. Each of these connections makes the gravastar hypothesis more than idle speculation. It transforms it into a possible unifying explanation for the universe's most violent mysteries. But with that possibility comes dread. For if gravastars are the source of these events, then their eruptions are not rare accidents, they are part of the natural rhythm of the universe. At the heart of the gravastar debate lies the struggle between theory and observation. General relativity predicts black holes with unyielding certainty, while quantum mechanics raises doubts about the singularities they require. Gravastars emerge as a bridge, an attempt to resolve contradictions between the two by replacing the singularity with something new. In this sense, gravastars are more than just astrophysical objects, they are the battleground where two of physics' greatest theories collide. If gravastars exist, they would serve as cosmic laboratories for testing these theories. The shell, made of exotic matter, could reveal physics beyond the standard model. The dark energy interior could connect to the mechanisms driving cosmic expansion. In them, relativity and quantum mechanics would meet, offering a glimpse at the long-sought unification of physics. But this promise is double-edged. The very qualities that make gravastars valuable for science also make them terrifying. Their shells may not be stable. Their interiors may not be permanent. And their behavior may not conform to the neat laws we expect. If gravastars truly bridge the gap between relativity and quantum theory, they might do so violently, tearing open flaws in our understanding as dramatically as their ruptures could tear open space. Gravastars would not just test our theories, they could destroy them. What makes gravastars particularly haunting is the thought that we might never know for certain if they exist. Even with advanced instruments, distinguishing them from black holes may be nearly impossible. Their mimicry is too perfect, their signals too faint, their differences too subtle. We may spend centuries studying the universe, believing we are surrounded by black holes, when in reality we are orbiting imposters. This uncertainty is itself a form of terror. Science thrives on clarity, on answers drawn from observation and proof. Gravastars deny us that certainty. They force us to live with ambiguity, with the possibility that the most powerful objects in the universe are not what they seem. And in this way, gravastars are worse than black holes, not because they are more destructive, but because they rob us of truth. Yet perhaps this is their most profound lesson. The universe is not here to comfort us with simple answers. It is here to challenge us, to mislead us, to force us deeper into the unknown. Gravastars embody that truth. They remind us that every shadow in the cosmos, every burst of energy, every ripple of space-time may conceal secrets still beyond our reach. Black holes may have terrified us with their hunger, but gravastars terrify us with their deception. The history of science is filled with moments when assumptions collapsed under new evidence. Once, Earth was thought to be the center of everything. Once, stars were believed to be fixed points in a crystalline sphere. Each time, new observations shattered the illusion. Gravastars could be the next shattering. If they are real, then black holes, the icons of modern astrophysics, were never what we thought they were. They were masks, illusions, placeholders for something stranger. And this possibility cuts deeper than just astronomy. Black holes have become cultural symbols of ultimate mystery, appearing in films, books, and popular imagination as the monsters of the universe. They represent the frontier of physics, the place where knowledge ends. If gravastars replace them, it will not only rewrite textbooks, it will rewrite our imagination of the cosmos. Instead of abysses, we must envision shells, thin, fragile boundaries containing the raw energy of expansion. That image is not just scientific, it is deeply unsettling. The thought of standing on the edge of a gravastar, if such a thing were possible, would be terrifying. Beneath your feet would be a shell thinner than imagination yet denser than any known matter. Below that, an ocean of dark energy, straining to break free. Above you, the universe, oblivious to the danger contained within. Gravastars turn the cosmos into a theater of tension, where stability is fragile and catastrophe is always possible. For all their terror, gravastars may also hold answers to some of the deepest questions in science. If their interiors are filled with dark energy, then they could offer direct evidence for the nature of the force that drives cosmic expansion. Dark energy is one of the greatest mysteries in physics, known only through its effects on galaxies. Gravastars, however, might contain it in concentrated form. Studying them could reveal what dark energy really is, whether it is a property of space, a new field, or something even stranger. But this research comes at a cost. To probe a gravastar is to disturb it. Observations from afar may one day reveal their fingerprints, but closer encounters, if humanity ever achieves them, could prove catastrophic. A probe striking the shell might release energy far beyond comprehension, destabilizing the object and triggering violent eruptions. Gravastars are not just dangerous because of what they are dangerous because of what they hide. In this way, gravastars mirror the paradox of discovery itself. They promise knowledge at the risk of destruction. They tempt us with answers but warn us with consequences. If black holes are nature's way of hiding truth, gravastars are nature's way of daring us to uncover it, while punishing those who try. The universe may already be littered with the corpses of gravastars that failed. Some astronomers speculate that certain hyperenergetic events, brighter than typical supernovae, could be the result of gravastars rupturing. These hypothetical explosions would release not only light and radiation but also floods of exotic particles and gravitational distortions. If so, then gravastars may not only exist, they may already have died, leaving behind chaos as their epitaphs. This possibility reframes cosmic violence. Where once we saw black holes as ultimate consumers, silently swallowing matter, we now imagine gravastars as unstable giants, capable of sudden, violent death. Their presence would mean that the cosmos is not merely a graveyard of stars, but a minefield of hidden bombs. Every galaxy, every cluster, every region of space might contain objects capable of rewriting their surroundings in a single catastrophic event. And the thought does not end there. If gravastars can rupture, then perhaps some of the cosmic radiation we detect, the strange background of high-energy particles that constantly bombard Earth, may be their fingerprints. The universe could already be whispering their story, scattering clues across space. We just have not yet realized what we are seeing. Gravastars may be everywhere, not only disguised as black holes but also leaving traces of their instability scattered across the cosmos. If gravastars exist, they could also redefine our understanding of time. Black holes stretch time near their event horizons, slowing it to a crawl for outside observers. Gravastars, though similar on the surface, may warp time in subtler, stranger ways. Their shells, dense beyond measure, could twist the passage of time differently than predicted by general relativity. And within their dark energy cores, time itself might behave in ways we cannot yet model. Some theorists even speculate that the interior of a gravastar could be timeless, an expanding vacuum disconnected from the flow of the universe outside. In this view, each gravastar is not only a collapsed star but a bubble universe, growing silently inside its shell. If true, gravastars could be more than astrophysical oddities, they could be gateways to multiverse. Every shell could contain a cosmos of its own, invisible to us, expanding behind the veil. This concept is not just scientific, it is haunting. It suggests that every gravastar may be hiding an entire reality within it, unreachable and unknowable. When we look at what we think is a black hole, we may in fact be staring at the surface of another universe, sealed off by an exotic boundary. Gravastars then become not only imposters but cosmic illusions, each one carrying infinite possibility within. The idea turns fear into awe, and awe into terror once again. The idea of gravastars containing hidden universes also reframes the cosmic balance. If each gravastar holds an expanding vacuum, then the universe itself may be full of hidden worlds. Billions of shells could be scattered across the cosmos, each one nurturing its own expansion behind an impenetrable barrier. In this way, gravastars might act as seeds of universes, budding realities that never breach their shells but grow eternally within. This perspective transforms the night sky. Instead of seeing a universe filled with voids, we might be surrounded by countless hidden realms, each one concealed behind a dark silhouette. The cosmos would not just be vast. It would be layered, filled with secrets upon secrets. And though we might never access these hidden interiors, their existence would force us to reconsider the meaning of creation itself. Perhaps universes are born not from singular big bangs, but from the quiet collapse of stars, each death giving rise to a new cosmos within. But if gravastars are indeed seeds of universes, then their rupture could have even more catastrophic implications. A breach might allow the energy of one expanding vacuum to leak into our own, destabilizing spacetime and creating chaos on unimaginable scales. In this scenario, gravastars are not merely dangerous, they are existential threats, their instability capable of unraveling entire regions of the cosmos. Some scientists argue that gravastars, if they exist, might actually be more stable than black holes in the long term. Without a singularity, they would avoid the paradoxes of information loss that plague black hole physics. Matter and energy striking their shells might leave signatures, echoes, or remnants that black holes would erase. In this sense, gravastars could preserve information rather than destroy it. To physicists, this is an alluring possibility. To storytellers of the cosmos, it is chilling. Because if gravastars do preserve information, they may serve as cosmic archives. Every particle, every star, every planet consumed by their shells could be encoded within their dense boundaries, locked away forever. Gravastars, then, become libraries of annihilation, tombs that record the very things they destroy. This is worse than oblivion. Instead of nothingness, gravastars offer eternal imprisonment. The idea of such archives scattered across the universe evokes dread. Imagine that the history of countless stars and civilizations lies buried in the shells of gravastars, unreachable and unreadable. The universe may already hold the records of everything it has consumed, but hidden in forms we cannot decipher. Gravastars do not just swallow, they keep secrets. And in doing so, they mock our attempts to understand them, reminding us that some truths will forever remain locked beyond reach. The possibility that gravastars preserve information challenges one of the deepest paradoxes in physics. Black holes, according to classical theory, erase everything that crosses their horizons. Yet quantum mechanics insists that information cannot be destroyed. This conflict, known as the information paradox, has baffled scientists for decades. Gravastars, however, offer an unsettling resolution: information is not destroyed, but imprisoned. The shell of a gravastar may encode the details of everything that collides with it. Instead of vanishing into a singularity, matter is compressed and trapped in an unimaginably dense boundary. If this is true, then gravastars are not just imposters, they are prisons of cosmic memory. Every atom, every photon, every event that meets their shells remains frozen into the structure, unreadable yet preserved. This reframes gravastars as monuments of cosmic history. They are silent witnesses, recording the lives and deaths of stars, the collisions of galaxies, perhaps even the remnants of civilizations. Yet these records are forever locked away, sealed behind barriers we cannot breach. In their silence lies both truth and terror. Gravastars preserve the story of the universe, but in a form we can never access. They are cosmic vaults, reminders that the universe keeps secrets more jealously than we can imagine. If gravastars are cosmic prisons, then their abundance may mean the universe is filling with locked archives of the past. Every stellar collapse, every galactic core may contribute to this hidden library. Over billions of years, the cosmos would become increasingly haunted by these sealed records, scattered across its vastness. The night sky would no longer be seen as filled with monsters of gravity, but with silent vaults of memory, each one guarding its own collection of secrets. This changes how we view cosmic death. Black holes offer finality. What falls in is gone, erased from existence. Gravastars offer something more disturbing, an eternal half-existence, where the matter and energy are not destroyed but trapped forever. This is not death, but imprisonment without end. Such a vision forces us to ask uncomfortable questions. What if our own galaxy's core, long believed to be a supermassive black hole, is in fact a gravastar? What if everything that has ever fallen toward its center is still there, encoded into the shell, fossilized but inaccessible? The center of the Milky Way may not be a void, but a monument, carrying the weight of billions of years of cosmic history within its thin, dense surface. If so, we are orbiting not a hole, but a vault, one that keeps the universe's deepest secrets locked in silence. The thought of gravastars as cosmic vaults also connects to an even more unsettling speculation: could they, in some sense, be alive? Not in the biological way we understand life, but as dynamic entities with memory, with the ability to change, with the potential to evolve. Their shells store information, their interiors pulse with energy, and their balance between collapse and expansion resembles a system more than a simple object. If gravastars are systems, not singularities, then their behavior could be far more complex than black holes. They may resonate, oscillate, or shift in ways we cannot yet predict. Some scientists have speculated about quasi-normal modes, vibrations within gravastars that could be detected as faint echoes. If so, then gravastars are not silent, they hum faintly in the language of spacetime itself. This blurs the line between object and process. Black holes are static endpoints, defined by simple properties like mass and spin. Gravastars, in contrast, may be dynamic, changing, resonant. They are more like living systems than dead ends. And this thought introduces a final layer of unease. If the most powerful objects in the universe are not dead voids but dynamic entities, storing memory, radiating faint echoes, threatening instability, then we are surrounded not by silence, but by whispers. Gravastars are not merely worse than black holes because of their danger. They are worse because they may refuse to ever truly die. The notion that gravastars might whisper through space-time raises the stakes of their detection. If their shells reverberate when struck by infalling matter, then every collision is not only a physical event but also a broadcast, an encoded message rippling outward. Gravitational wave detectors may one day decode these faint signals, uncovering information about the hidden structure of gravastars. But what would those echoes reveal? Perhaps details about their shells, their interiors, or even the history of what they have absorbed. This makes gravastars more than passive actors. They become communicators, though not by intent. Their very nature may force them to radiate faint signals when disturbed. The terrifying implication is that the universe could already be full of these whispers, but we lack the sensitivity to hear them clearly. Our instruments may only catch fragments, scattered like static, while the true song of the gravastars remains buried beneath cosmic noise. If one day we do hear them clearly, what then? Will we learn that gravastars are stable, eternal guardians of hidden energy? Or will we discover instability written into their echoes, signs that these cosmic shells are ticking toward catastrophic rupture? The answers may not comfort us. For sometimes, hearing the truth is worse than silence. The possibility of gravastar rupture is the most chilling of all. If one of these objects fails, the release of its dark energy core could be apocalyptic. A stellar mass gravastar might produce an eruption brighter than a hypernova, a burst that could sterilize entire regions of space. A supermassive gravastar, seated at the heart of a galaxy, would be far worse. Its detonation could unleash enough energy to destabilize the galactic core, scatter stars, and disrupt the very orbit of systems like our own. Some theorists argue that such eruptions might be indistinguishable from the most powerful cosmic explosions we already observe. Perhaps some gamma-ray bursts are not dying stars but ruptured gravastars. Perhaps some unusual supernovae are not collapses but releases. If so, then gravastars are not just hypothetical, they may already have scarred the cosmos with their violence. And yet, we might never know. The universe hides its catastrophes behind distance and time. By the time we detect these bursts, they have already happened millions or billions of years ago, in galaxies far beyond our reach. Gravastars may already be exploding across the universe, reshaping distant galaxies, while we watch only the fading afterglow. To us, they are curiosities. To their galaxies, they are endings. If gravastars can rupture, then they are more than imposters, they are threats. Black holes, for all their destructive power, are predictable. They grow, they merge, they radiate slowly, but they do not explode. Gravastars, on the other hand, are unpredictable. They hold within them the same energy that drives the universe's expansion, restrained only by thin, fragile shells. Their very existence is a gamble, balancing forces that could fail catastrophically at any moment. This unpredictability makes gravastars worse than black holes. With black holes, the terror lies in inevitability. Once you cross the horizon, there is no return. With gravastars, the terror lies in uncertainty. They may sit silently for billions of years, or they may rupture tomorrow. Galaxies may orbit their cores peacefully for eons, only to be shattered by a single eruption. The universe may appear stable, but beneath that stability lurks fragility, waiting for cracks to form. The Gravastar hypothesis forces us to accept a darker vision of the cosmos. Not a universe governed by clean, predictable laws, but a universe of illusions, instability, and deception. The night sky becomes not a map of certainty, but a theater of masks. Behind each shadowy void may lie not a black hole, but something worse, an object that pretends to be eternal while hiding the seeds of violent death. Gravastars, if real, would prove that the universe itself is far more treacherous than we ever imagined. If gravastars are real, then they demand that we rethink cosmic safety itself. In the black hole model, galaxies can coexist peacefully with their central monsters. Stars orbit around them, nebulae drift nearby, and only those that venture too close are devoured. The rules are terrifying but stable. Gravastars rewrite those rules. Their silent instability means that entire galaxies may live under the shadow of sudden catastrophe, oblivious to the danger ticking away at their core. Imagine the Milky Way. At its center lies Sagittarius A*, thought to be a supermassive black hole. But if it is instead a gravastar, then the heart of our galaxy is not a silent void, but a fragile shell holding unimaginable energy. For billions of years, it may remain calm, but if that balance fails, the resulting explosion could tear apart the galactic core, sending shockwaves that destabilize the orbits of stars, including our Sun. We orbit in safety only because the shell still holds. Our galaxy may be a cosmic candle, burning quietly while hiding the fuel for a sudden, devastating flame. This thought reframes the universe itself. Every galaxy, every cluster, every dark core we observe may be carrying its own hidden risk. Gravastars transform the cosmos into a minefield of possibilities, silent, scattered, waiting. The Gravastar hypothesis also forces us to confront the role of deception in nature. Throughout history, the universe has cloaked its truths in illusions. The Earth seemed flat until perspective revealed curvature. The stars seemed eternal until physics revealed their life cycles. Black holes seemed final until gravastars questioned their reality. Nature is a master of disguise, and gravastars may be its most perfect illusion yet. This deception is not intentional, it is the product of physics itself. Gravastars warp spacetime so effectively that they mimic every outward property of black holes. To our instruments, they are indistinguishable. To our theories, they are plausible. To our imaginations, they are terrifying. And perhaps that is the ultimate lesson, that the universe is not obligated to reveal its monsters honestly. It hides them, cloaks them, and forces us to search deeper for truth. But this concealment creates a profound unease. If we cannot tell the difference between a black hole and a gravastar, then how many other illusions still haunt the universe? How many other certainties are only masks? Gravastars remind us that our knowledge, no matter how advanced, is always provisional. The cosmos is not a solved puzzle, but a shifting labyrinth of truths and lies. Some scientists dismiss gravastars as unnecessary speculation. Black holes, they argue, already explain the data elegantly. Why replace a working model with a more complex one? But this dismissal may itself be dangerous. Throughout science, progress often comes not from clinging to what works, but from daring to question it. Gravastars may not yet have proof, but neither can black holes claim certainty. Both remain interpretations of evidence, and the evidence itself may be incomplete. This tension between skepticism and imagination is at the heart of science. Gravastars challenge us to imagine alternatives, to accept that the universe may not conform to our neatest theories. They remind us that every observation carries assumptions, and every assumption may someday collapse. Whether gravastars exist or not, their hypothesis forces us to sharpen our questions, refine our instruments, and expand our vision. And if they do exist, then the very foundation of astrophysics will shift. Black holes will fall from their throne as the ultimate cosmic monsters, replaced by imposters whose danger lies not only in their power but in their deception. Gravastars would become symbols of a darker truth, that the universe is stranger, less stable, and more treacherous than we dared believe. The mystery of gravastars is not only scientific, it is existential. They embody the unsettling truth that the universe may not operate according to our expectations. Black holes, as terrifying as they are, still fit within the neat mathematics of general relativity. Gravastars, however, live in the margins, halfway between collapse and expansion, between stability and chaos. They are reminders that reality does not bend to human intuition. It builds structures that look impossible, then hides them in plain sight. For civilization seeking certainty, gravastars are the worst revelation. They say, you are not safe, even when you think you are. You orbit galaxies whose cores could, without warning, erupt with unthinkable violence. You map the stars, believing in steady rules, but beneath those rules are objects that laugh at your simplicity. Gravastars destabilize not only galaxies, but also our sense of truth itself. They whisper that knowledge is fragile, and that the universe is under no obligation to reveal itself clearly. In this way, gravastars are cosmic riddles. They demand humility, forcing us to admit that we may never have the full picture. And perhaps that is their greatest terror. Not their power, not their violence, but the reminder that the deepest mysteries may forever remain hidden, sealed inside shells we cannot pierce. The Gravastar hypothesis also intersects with the study of cosmic origins. If these objects are repositories of dark energy, then they may offer insights into the very birth of the universe. Some scientists speculate that the Big Bang itself could have been the rupture of a gravastar-like structure, a shell containing energy that finally gave way, unleashing creation. If so, then gravastars are not only stellar corpses but echoes of the same mechanism that birthed everything. This would mean that gravastars are more than the future of collapsed stars, they are reflections of the past. Each one would be a miniature replay of creation itself, a bubble of expansion sealed behind a shell. To study them would be to study the blueprint of the cosmos, written not in galaxies or stars, but in fragile vaults of energy scattered across the void. The idea unsettles the mind. If every gravastar is a failed universe, then the cosmos may be littered with seeds of creation that never grew. Our universe may not be unique, it may simply be the one bubble that ruptured large enough to expand freely. Gravastars, then, are monuments to possibility. They are both tombs and wombs, holding in their shells the energy of creation but refusing to release it. And should one rupture, the echoes of the Big Bang might play out again on a smaller scale, rewriting entire regions of the cosmos. In the end, gravastars may remain forever unproven. Their mimicry is too perfect, their signals too faint, their disguises too complete. We may search for centuries and never know with certainty whether a given shadow in the sky is a black hole or a gravastar. This uncertainty is maddening, but it is also the essence of science at the frontier. The boundaries of knowledge are not sharp, they are blurred, filled with speculation, doubt, and mystery. But perhaps this is fitting. The universe is not a solved puzzle, waiting for us to assemble the last piece. It is a shifting landscape, full of illusions and deceptions. Gravastars embody that reality. They remind us that even when we believe we have uncovered the ultimate truth, there may be layers still hidden beneath. And that is why gravastars are worse than black holes. Black holes frighten us with certainty, with inevitability, with finality. Gravastars frighten us with uncertainty, with deception, with instability, with truths we may never fully grasp. They are cosmic imposters, vaults of hidden energy, whispers of dark possibility. They may be rare, or they may be everywhere. They may remain silent forever, or they may erupt tomorrow. In their uncertainty lies their terror. And in their terror lies the most profound lesson of all, that the universe is not built to comfort us. It is built to remind us how little we know. The gravastar, at its core, is not simply a scientific hypothesis, it is a challenge to our imagination. For decades, black holes have served as the ultimate symbol of cosmic mystery. They are terrifying, yes, but they are also straightforward in their rules: cross the horizon and you are gone. Gravastars are worse because they replace certainty with ambiguity. They are hollow where we expected density, expanding where we expected collapse, fragile where we expected permanence. They are, in essence, contradictions made real. These contradictions mirror the paradoxes of physics itself. Gravity says collapse must continue forever, but quantum theory whispers that infinities cannot exist. Gravastars embody the uneasy truce between these voices. They are the compromise that neither theory fully accepts, yet both must contend with. And perhaps that is their true horror: they exist in the gap between what we know and what we cannot yet unify. They live in the fracture of our understanding. To confront gravastars is to confront the possibility that the universe thrives in contradictions. It does not choose simplicity. It chooses tension, paradox, disguise. Gravastars do not merely replace black holes, they mock our desire for clean answers. They are a cosmic reminder that truth itself may always be layered, unstable, and incomplete. If gravastars fill the universe, then they reshape the story of galactic evolution. Black holes, in the traditional model, are anchors. Their immense gravity holds galaxies together, stabilizing their cores and guiding their structure. Gravastars, by contrast, are not anchors, they are fragile shells masking volatile interiors. If galaxies orbit these imposters, then the balance of the cosmos is more precarious than we imagined. Consider a merger between two galaxies, each with a gravastar at its core. As the galaxies collide, their central gravastars might spiral toward one another. If they merge peacefully, the result could mimic the gravitational wave signatures of black hole collisions. But if their shells rupture under the stress, the explosion could devastate both galaxies, scattering stars, stripping away gas, and reshaping their very structure. Entire civilizations, scattered across countless star systems, could be erased in a single cosmic heartbeat, all because the universe prefers fragile shells to infinite voids. This thought reframes galaxies themselves. They are not serene islands of stars drifting through space, but fragile systems dancing around hidden bombs. Gravastars turn cosmic beauty into cosmic suspense. Every glowing spiral and majestic elliptical may be balanced upon the shell of an impostor, waiting in silence for instability to reveal its true nature. The search for gravastars continues, though the odds of proof remain slim. Astronomers hunt for subtle differences: the flicker of light, the echo of a wave, the anomaly in a burst. Each potential clue sparks debate, each anomaly fuels speculation. Yet the truth remains elusive. Gravastars hide too well, their mimicry too perfect, their signals too faint. For now, they remain ghosts, half believed, half doubted, suspended between theory and reality. And perhaps that is their final deception. The gravastar is not only a challenge to physics, but also to certainty itself. We crave answers, final truths, comforting conclusions. Gravastars deny us this. They say, you may never know. You may orbit imposters forever, mistaking masks for reality. You may map the universe in false names, never uncovering the true structures beneath. This is why gravastars are worse than black holes. Black holes are brutal but honest. They tell us what they are, even if we cannot see them directly. Gravastars lie. They promise one truth while hiding another. They may be stable, or they may explode. They may be rare, or they may be everywhere. Their disguise is their weapon, and their uncertainty is their power. In the silence of the cosmos, gravastars wait, not to be discovered, but to remind us that the universe will always remain one step ahead of our understanding. The terror of gravastars lies not only in their existence but in their silence. Black holes announce themselves with violence, matter swirling around them glows brightly, radiation pours into space, jets of plasma scream across light years. Gravastars, on the other hand, could be quieter. Without an event horizon, they may not consume matter in the same way, instead bouncing it against their shells or absorbing it in subtle ways. From afar, they would appear less dramatic, less obvious. They would blend into the background of the universe, overlooked precisely because they are quieter than their black hole counterparts. This silence is deceptive. It allows gravastars to persist unnoticed, masquerading as ordinary black holes. Astronomers searching for dramatic signals might miss them entirely, assuming that quietness means emptiness. In truth, that quietness may hide fragile shells filled with dark energy, objects that are far more unstable than black holes but infinitely harder to catch in the act. The cosmos may already be full of gravastars, and we may be staring at them without realizing. Their silence, then, is not peace, it is tension. It is the stillness before an eruption, the calm before collapse. Gravastars do not roar like black holes. They whisper. And whispers, when ignored, can be far more dangerous than screams. If gravastars rupture, the scale of destruction is almost incomprehensible. Consider the amount of dark energy contained within even a small gravastar. Dark energy is not just powerful, it is expansive. It drives the acceleration of the entire universe. For a gravastar, this energy is sealed tightly inside, pressing constantly against its shell. A rupture would not merely release radiation, it could distort the very geometry of space around it. Some theorists suggest that such an event could cause localized bubbles of accelerated expansion. A star system unlucky enough to exist nearby might be ripped apart, not by heat or radiation, but by space itself stretching at unnatural speeds. Planets would drift away from their suns, orbits would dissolve, and the fabric of the cosmos would betray its inhabitants. In extreme cases, a gravastar rupture might even seed new universes, spilling its expanding core outward into our own. This possibility reframes the gravastar as not just a stellar corpse, but a cosmic weapon. Its detonation would not be limited to a single region, it could reshape spacetime itself. The universe becomes more fragile when gravastars exist. Each one is a locked door, behind which lies the potential for unmaking reality. Why, then, do gravastars matter so much? Because they challenge our greatest scientific assumptions. For a century, black holes have been the ultimate test of relativity, the endpoints of stellar collapse, the anchors of galaxies. They have been our certainty in a universe of unknowns. Gravastars strip that certainty away. They tell us that the objects we thought we understood may be imposters, that our models may be wrong, that the very foundation of astrophysics may be shakier than we believed. This is not failure, it is revelation. Science thrives not on comfort, but on discomfort. Gravastars force us to push harder, to refine our tools, to question our assumptions. They remind us that no theory is sacred, no model permanent. Even the icons of physics can fall. And yet, this does not diminish the fear. Because while gravastars may expand knowledge, they also expand uncertainty. They are worse than black holes because they replace a clean monster with a messy one, a predictable abyss with an unpredictable shell. They take what we thought we knew and turn it into a mask. And when the mask comes off, we may discover that the universe is not only stranger than we imagined, it is stranger than we can imagine. The question of evidence remains the most pressing. How can we ever be sure gravastars exist if they mimic black holes so perfectly? The answer may lie in the faintest details. Some simulations suggest that when matter collides with a gravastar's shell, it would produce a brief, unusual flash of radiation. Unlike the steady accretion glow of a black hole, these bursts would be erratic, unpredictable, signs of impact against a physical boundary rather than a plunge into nothingness. Detecting such flashes requires instruments of incredible precision, but new telescopes may soon have that capability. Gravitational waves offer another possible clue. When two black holes merge, the resulting signal fades smoothly. But if gravastars collide, the shell vibrations could create faint echoes. Subtle reverberations after the main event. Researchers analyzing LIGO and Virgo data have claimed to see hints of such echoes, though the evidence is far from conclusive. Still, the possibility lingers. Perhaps the proof has already been recorded, hidden in the static of spacetime's tremors, waiting for sharper ears to uncover it. Until then, the debate remains alive. Black holes may dominate textbooks and headlines, but gravastars haunt the edges of the data. They are the shadows behind shadows, the possibilities behind certainties. Their greatest weapon is their disguise, and their greatest mystery is that they may already have revealed themselves, we simply have not recognized them. The philosophical consequences of gravastars are profound. Black holes represent finality, the end of matter, the swallowing of information. They embody inevitability. Gravastars, however, are ambiguity made physical. They blur the line between existence and non-existence, between stability and collapse. They are not endpoints but paradoxes, objects that should not exist and yet might. This ambiguity reflects back on us. If gravastars are real, then the universe itself is not built on clean lines but on contradictions. It does not choose simplicity, it chooses deception. Gravastars would prove that nature prefers disguise to revelation, complexity to clarity. For those seeking ultimate truth, this is unsettling. It suggests that the cosmos may always withhold its deepest secrets, offering us illusions instead. And perhaps that is the ultimate reason gravastars are worse than black holes. Black holes horrify us with their certainty, they are inescapable, eternal, absolute. Gravastars horrify us with uncertainty, they may erupt or remain stable, they may store or erase, they may mimic or betray. They are cosmic liars, wearing the mask of black holes while hiding something stranger beneath. Their lesson is harsh but necessary, never assume the universe shows its face honestly. Some thinkers take the gravastar idea even further, asking whether such objects could play a role in the deepest cycles of the cosmos. If gravastars contain dark energy in concentrated form, could their ruptures be responsible for shaping the universe itself? Perhaps the Big Bang was not a unique event, but the greatest rupture of all, the shattering of a cosmic gravastar larger than anything we can imagine. In this vision, our universe is born from instability, from the same process that may still echo across galaxies today. This would mean that gravastars are not merely byproducts of dying stars, but the engines of creation. Every rupture would not just destroy, it would seed. It could launch a new bubble of space-time, a miniature universe expanding invisibly alongside our own. Our cosmos, then, may be one of many, born from a chain of ruptured gravastars in a larger, unknowable meta-universe. The speculation is dizzying, but it highlights the true power of the gravastar hypothesis. It is not just about explaining strange data or replacing black holes. It is about rewriting our understanding of reality itself. If gravastars exist, then every dark shadow in the sky may not be an abyss, but a womb. Every galaxy may orbit a vault of creation, fragile yet immense. And our own existence may be tied, in ways we cannot yet grasp, to the silent, waiting shells of these cosmic impostors. The Gravastar idea also raises unsettling questions about cosmic evolution on the grandest scales. If black holes are truly impostors, then the entire narrative of how galaxies form and grow may be flawed. In the Standard Model, supermassive black holes act as engines of galactic life, shaping star formation with their immense gravity and powerful jets. But if those objects are gravastars, then galaxies may be evolving under very different rules. Instead of engines, they are balanced on fragile containers of dark energy, more precarious, more unpredictable. This reimagining destabilizes more than astronomy. It forces us to question the way we tell the story of the cosmos. Science often frames the universe as orderly. Stars are born, they live, they die, and their remnants follow predictable fates. Gravastars interrupt this order. They are neither alive nor dead, neither stable nor collapsing. They are liminal objects, sitting on thresholds rather than endpoints. They complicate the narrative, transforming cosmic history into something less like a clean arc and more like a haunting mystery novel, full of impostors, disguises, and hidden catastrophes. And in this way, Gravastars embody the darker character of the cosmos. They remind us that not all endings are final, and not all shadows are what they seem. Galaxies may not be built on certainty, but on deception, stability built on shells that could rupture without warning. For those who study the philosophy of science, Gravastars highlight a deeper tension, the conflict between what is observable and what is true. We cannot observe black holes directly, we infer them from their effects. Gravastars exploit that gap. They behave almost identically in every way we can measure, leaving us trapped between two possibilities. Which is real? The answer may never come with certainty. This gap in knowledge is unsettling because it forces us to accept limits. Science thrives on expanding boundaries, yet Gravastars present a boundary we may never cross. Unless their shells rupture, or unless technology advances unimaginably, we may never see beyond their disguises. The cosmos may always withhold their secret, leaving us forever guessing. And perhaps this uncertainty is why Gravastars are so terrifying. Black holes frighten us because they end stories, they swallow matter, erase information, halt time. Gravastars frighten us because they refuse to end the story. They leave us in suspense, trapped in a perpetual cliffhanger. They are the ultimate what-if, lurking in every dark shadow of the sky, never confirming or denying their existence. Their power is not just physical, it is psychological. They force us to live in ambiguity, never certain of the truth. The more we imagine Gravastars, the more they resemble cosmic tricksters. Nature often plays tricks at the extremes. Mirages in deserts, illusions of motion in the stars, paradoxes at the speed of light. Gravastars are the ultimate cosmic mirage. From a distance, they are black holes. Up close, they are fragile shells hiding expansion energy. Their trick is so perfect that even the most advanced instruments may fail to reveal it. But unlike harmless illusions, this trick has consequences. If Gravastars rupture, they unleash devastation. If they exist, they destabilize our theories. If they hide, they corrupt our observations. In this sense, they are not just imposters, they are saboteurs, undermining both science and stability. The universe itself seems to mock us through them, saying, even your best models can be lies. This realization forces humility. We cannot assume that the most terrifying objects we know are the final word. There may always be a deeper trick, a darker impostor, a stranger truth. Gravastars remind us that the universe is not obligated to be clear, and that our confidence is often the first illusion to collapse. They are cosmic jokes, but jokes with catastrophic punchlines. And the laughter, if it exists, belongs not to us, but to the universe itself. The danger of Gravastars also lies in their invisibility as threats. A supernova can be anticipated, its dying star showing signs of instability before it detonates. Even black holes, for all their mystery, are relatively predictable in their behavior. But gravastars may give no warning. Their rupture could be sudden, their eruption instantaneous. A galaxy could orbit peacefully for billions of years before its central gravastar tears open, obliterating everything in its reach. This unpredictability introduces a new kind of cosmic horror, the silent apocalypse. Civilizations thriving near galactic cores might believe they are safe, their stars orbiting in perfect order. Yet all the while, the heart of their galaxy may be a fragile shell, holding back energy far beyond comprehension. When that shell breaks, no technology, no escape velocity, no amount of preparation could save them. Gravastars turn cosmic safety into illusion, promising stability but hiding destruction. And this is why gravastars are worse than black holes. Black holes consume, but gravastars betray. They lure us into believing we understand them, into thinking we orbit stability, only to reveal fragility at the worst possible moment. They are not just killers, they are deceivers. Some scientists suggest that gravastars might leave subtle clues in the cosmic background itself. The faint afterglow of the Big Bang, the cosmic microwave background, carries patterns of radiation that reveal the universe's structure. If gravastars have ruptured throughout cosmic history, their explosions may have left faint imprints on this background, distortions too subtle to attribute to normal processes. Detecting such fingerprints would be nearly impossible, but if found, they would rewrite cosmology. Another possibility is that gravastars could emit exotic particles upon rupture, particles that standard physics cannot explain. Some anomalies in high-energy cosmic rays, streaming constantly toward Earth, may hint at such origins. If gravastars are behind them, then we are already surrounded by the debris of their instability, bombarded daily by particles born from ruptures millions or billions of light-years away. These ideas transform gravastars from speculation into possibility. They suggest that the evidence may already be here, scattered across radiation fields and particle detectors, waiting for us to connect the dots. But until we do, gravastars remain ghosts, half-glimpsed, half-doubted, haunting the edges of science. The cultural impact of gravastars would be immense. Black holes have already captured the human imagination, serving as metaphors for oblivion, inevitability, and the unknown. Gravastars, if proven real, would replace this imagery with something darker. They would symbolize deception, fragility, and hidden danger. They would become icons not of finality, but of uncertainty, a reminder that the universe wears masks. Philosophers might use gravastars to illustrate the limits of perception, the dangers of assuming that what we see is what is real. Artists might depict them as hollow spheres, fragile shells glowing faintly with imprisoned light. Writers might reimagine them as cosmic tricksters, luring civilizations with false stability before unleashing ruin. Gravastars would shift humanity's cultural relationship with the cosmos, forcing us to confront not only the terror of annihilation, but the deeper terror of never truly knowing. This cultural weight is part of why gravastars are worse than black holes. Black holes, for all their horror, give us certainty. Gravastars deny it. They leave us trapped in ambiguity, forever unsure whether we orbit truth or illusion. In doing so, they change not only science, but imagination itself. If gravastars truly populate the universe, then we are surrounded not by the clean certainty of black holes, but by deception at a cosmic scale. This changes how we must view every observation. The swirling disks of gas we see at galactic centers, the jets of plasma stretching across light-years, the gravitational waves rippling through detectors, all of it may belong not to black holes but to imposters. The foundation of astrophysics would have to be rebuilt, brick by brick, under this new assumption. This would not be the first time science has faced such upheaval. The discovery that Earth orbits the Sun, that the Milky Way is only one of billions of galaxies, that the universe is expanding, all shattered old certainties. Gravastars could be the next revelation, one that cuts to the heart of modern physics. And as with past discoveries, the initial response may be denial. Many will argue that black holes remain the simpler, more elegant solution. Yet nature does not always prefer simplicity. Sometimes it chooses complexity, contradiction, and disguise. In this sense, gravastars represent not only a scientific challenge but also a psychological one. They force us to live with uncertainty, to admit that even our most cherished theories may be masks. They teach us humility before the cosmos, a humility born from the recognition that truth may never come in clean lines. One of the most haunting aspects of gravastars is their fragility. The very concept is built on balance, gravity pulling inward, dark energy pushing outward, the shell caught in between. Such a balance cannot last forever. Even if gravastars endure for billions of years, time itself may conspire to break them. Accretion of new matter, tidal stresses from cosmic interactions, or the sheer instability of exotic matter could one day rupture their shells. If this is true, then gravastars are temporary, cosmic time bombs waiting for their moment. Some may rupture quietly, scattering radiation across the void. Others may erupt with the force to rival entire galaxies, altering the course of cosmic evolution. Perhaps the most violent events we have witnessed, those bursts that defy explanation, are already gravastar ruptures in action. This possibility casts the universe in a darker light. It suggests that beneath the calm of the stars lies a constant threat, invisible and unpredictable. Gravastars may not only replace black holes in theory, they may add an entirely new layer of cosmic danger, one that turns stability into illusion. The universe, instead of being ruled by silent consumers, may be filled with fragile vaults that could fail without warning. The Gravastar hypothesis also hints at deeper mysteries. If these objects exist, then what, exactly, are their shells made of? Ordinary matter cannot withstand the pressures required. Theorists propose exotic states, quantum fields, superfluids, or particles beyond the standard model. Each possibility carries profound implications. A gravastar shell could be the most extreme laboratory in the universe, holding answers to questions about quantum gravity, particle physics, and the nature of space-time itself. But such answers come at a cost. To study a gravastar is to confront an object that may erupt catastrophically if disturbed. Even in imagination, sending probes near one feels reckless. The shell would be harder than any known surface, the environment more extreme than any black hole horizon, the risks unimaginable. And yet, the knowledge it holds is irresistible. Gravastars are both dangers and treasures, vaults not only of energy but of truth. In this duality lies their essence. They are worse than black holes not just because they threaten galaxies, but because they tempt us. They dangle secrets in front of us, locked behind fragile shells, daring us to come closer, daring us to risk everything for knowledge. They are the universe's cruelest bait, knowledge wrapped in danger, truth wrapped in disguise. As the debate over gravastars continues, the question is no longer simply scientific, it is existential. Are we truly surrounded by the monsters we think we know, or by imposters hiding in plain sight? If gravastars exist, then our universe is far more deceptive than we imagined. Every so-called black hole may instead be a fragile shell, each galaxy's stability balanced on a cosmic lie. For astronomers, this is not just a matter of classification. It is the difference between a universe ruled by clean inevitabilities and one haunted by instability. If black holes dominate, then the cosmos is brutal but orderly, matter falls, horizons form, singularities grow. If gravastars dominate, then the cosmos is unpredictable, shells rupture, energy escapes, galaxies shatter. One universe offers grim certainty. The other offers terrifying ambiguity. And in this ambiguity lies the true power of the gravastar hypothesis. It forces us to confront not only what we know, but what we cannot know. It dares us to accept that the universe may never reveal its monsters honestly, that disguise and deception may be as fundamental to reality as gravity itself. The greatest fear is not that gravastars exist, it is that we may never prove they do. Their mimicry is too perfect, their signals too faint. Every observation we make can be explained away as a black hole, every anomaly dismissed as noise. Gravastars may remain forever in limbo, unconfirmed, unrefuted, haunting the margins of theory. This uncertainty is worse than ignorance. With ignorance, there is hope for answers. With gravastars, there may never be clarity. We may orbit our galaxy's core for billions of years, never knowing if it is a black hole or a gravastar. We may witness bursts of radiation, never certain if they are dying stars or ruptured shells. We may map the cosmos, never sure if the shadows we label as black holes are actually vaults of dark energy. Gravastars turn the search for knowledge into a perpetual suspense, a cosmic riddle without solution. And perhaps this is their truest horror, they deny us closure. They leave us suspended between truth and illusion, certainty and doubt. They are cosmic cliffhanger, forcing us to live with the possibility that the universe itself may never tell us the full story. So, are black holes a lie? Perhaps not entirely, but perhaps they are only half the truth. Gravastars may lurk behind the shadows, masquerading as the monsters we thought we understood. If so, then the universe is filled not with infinite abysses, but with fragile shells, each containing the raw force of expansion, each waiting silently in the dark. This possibility is not just scientific speculation, it is a reimagining of the cosmos itself. It replaces certainty with doubt, inevitability with fragility, honesty with deception. It tells us that the universe is not a place of clear answers, but of masks and imposters. And behind those masks may lie dangers greater than we ever feared. In the end, perhaps that is the final lesson of Gravastars, that the universe is stranger than our imagination, more unstable than our theories, more deceptive than our senses. Black holes taught us to fear inevitability. Gravastars teach us to fear uncertainty. And in that uncertainty, they become far worse. The night sky is filled with shadows. Some may be black holes. Some may be gravastars. We may never know which is which. But as we stare into those dark voids, one truth becomes clear: the universe does not promise clarity. It promises mystery. And gravastars, whether real or not, are the embodiment of that promise. With that, our journey ends. The cosmos has revealed its tricksters, its imposters, its silent shells. Whether gravastars exist or remain theory, they remind us of a truth more terrifying than any collapse, that the greatest danger in the universe may not be what we see, but what hides behind the mask of what we think we know.